Okay, Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. Hi everybody. Hope you be safe at home and then stay at home, don't go anywhere. Okay, so now we continue what we have left. One more, okay, transformation, which is differentiation. Okay, as before, we have xt as an input signal, xt the original signal, and then it go through a differentiator. Okay, we have a system here which is differentiator, because we do a differentiation transformation of the original signal xt, and then the output of this system or differentiator is dxt over dt. Okay, so it's differentiator system. Okay, so we do a differentiation transformation of xt. Okay, over here. So the most important thing, just to remind you, we have two ways to model or to represent our signal xt over here, which is in mathematical equation and graph. So when we want to do differentiation, so we can do both way or both representation, whether mathematical equation or graph. Okay, so first now, okay, we look into the first approach, okay, which is the mathematical equation over here. So for example, we have for first question, okay, we have xt equal to t power of 2 plus t. Okay, so the output of this system, if our input is t power of 2 plus t, so we have 2t plus 1, where we differentiate this function. Okay, same goes to for example number 2. If we have et, okay, differentiation of et is equal to et. Okay, this is et. So when we differentiate et, we have et. Okay, so when we differentiate e to t, where we differentiate e to t, so we have e to t, and then we multiply differentiation of this power, which is differentiation of 2t is 2. So de to t, differentiation of this function is 2e to t. Okay, so if you look into number 4, you see this one number 4, and then number 5, and number 6. Okay, this one number 6. Okay, so cos t, if we have xt as a cos t, so we know differentiation of cos t. Okay, differentiation of cos t will give you negative sin t, and then okay, this one is very important. Okay, this one is like a general function that when we differentiate, or this is what we call that, the identity for differentiation that you need to know. So when we differentiate dut dt, so we will get impulse function. Okay, and then for this one, differentiation of dt of ut plus 1 ut minus 1, which is our rectangular function. Okay, like this one, where negative 1, 1, and then 1. Okay, so ut plus 1 minus ut minus 1, as differentiation of ut is impulse function, of course we will get impulse function ut plus 1 ut plus 1 minus t minus 1. Okay, alright, so now this is the first method where we use mathematical equation, where we straight away differentiate the function. Okay, so this is the first approach, which is mathematical equation. So we have the second approach, which is using graph. Okay, the second approach where we can use graph. Okay, for this example, I will try to take our rectangular signal here. Okay, so we have ut plus 1. We first take our step function ut, our xt, as the input signal of xt, which is ut. So we know, because this one is a graph, okay, graph method, so we have you need to draw the graph of unit step function 0 and 1. Okay, so if you look carefully, okay, the signal go from here, and then after that increase to 1, and then after that maintain at 1. Okay, so this the how the function of ut look like. Okay, So we need to differentiate this. Okay, we need to, for graphical method, you need to divide the graph into section. Okay, so for example over here we can see this one, the first section, and then you must also include the transition, okay, as a section. So here this transition is a second section, and then you have this maintain part is for the third section, and then we divide according to the section. Okay, so for the first section, okay, so D0, because we have 0 here, so differentiation of 0. Okay, so this is our dx dt, which is d ut, our differentiation of c. So based on the section number 1, differentiation of 0 is equal to 0, so you got 0 over here. Okay, differentiation of transition. Okay, this one is very important, the identity. So if you have transition, because it's increased, so we will get this transition, differentiation of this transition will give you impulse function. Okay, alright. Of the impulse function depending on the increase, okay, of your graph over here. Since you have it increased by 1, so you have positive 1, okay, over here. And then differentiation of 3, section 3 over here, which is 1, differentiation of constant 1 is 0. Okay, so like that. So this is the result, okay, of differentiation of ut, which is we got impulse function delta t. Okay, this one 0. So we can represent as del ut dut dt, differentiation of unit step function is equal to impulse function as over here. Okay, this one. Okay, where differentiation of ut is equal to delta t. Okay, so if we take another example over here, so we have our rectangular signal, okay, which is t and 1, and then when we differentiate this one, of course we need to know where how the graph look like. For example, it go from left and then go up, and then we make a section of this graph. Okay, this one is first section, and then this one the second section, third section, fourth section, and we have fifth section over here. And then we differentiate according to the section. Okay, remember. Okay, the first section, differentiation of 0. Okay, of course you will get 0. Okay, differentiation of transition. Okay, this one transition. Okay, transition. Okay. Okay, this one you will get impulse function because it's increased by 1, so the amplitude will become 1. Differentiation of 1 is 0. Okay, for section number 3, and then for section number 4, is this a transition? It gives you impulse function, but now, the transition go from 1 to 0, which is decrease in terms of the amplitude. So you need to decrease in terms of amplitude. Of course, decrease by what? By negative 1. So the amplitude become negative. And then for the last section, which is the fifth one, okay, because differentiation of 0, we will get 0. Okay, this is the result of integration by graph for our rectangular signal ut plus 1 minus ut minus 1. Okay, so we can write this, okay, because we can translate or represent the intermathematical equation. So we can get this one is delta t plus 1, okay, minus delta t minus 1. Minus is because we have minus negative amplitude over here. Okay, so now we have the, so for differentiation we have two methods. Okay, so first is mathematical method, and also the second one is the graphical method. Okay, so you can either use both, you can either use one of it. Okay, alright, hopefully you can understand this. Okay, so just leave in the comment if you don't understand. Okay, thank you.